So for our biggest client and for our biggest project that we are working on as Arkansas, 2 years ago we started publishing our first events. Right now we have 13 millions of them. And frankly, I had no idea 2 years ago what we were getting into. It wasn't my idea to start to publish those events. I wasn't so convinced. I didn't know what we were doing, how much it's gonna change our code base, whether it's gonna be a good thing or bad thing. I didn't know any of these things at all. So, and I'm still not an expert, but at least I've got 13 million events in my database, so I know something. Okay, just like GitHub. Except they have like bad payload. I have good payload. And so the first step Andre already told you yesterday, and I'm gonna show you where we got 2 years later. Oh, I don't need Wi-Fi. Yeah. So in those 2 years, we had like quite a journey. It's not like if you start publishing events, you're gonna have the Saga pattern that I'm going to talk about like next week. It's probably not gonna happen. But maybe sometime later, you will achieve the ability to use it, to understand, to get the benefits of it, okay? So it's not gonna be also only about Saga pattern, it's gonna be also in the way that got us there. So the assumption is that you have a message-driven architecture in your application, and usually it's called event-driven architecture, but I prefer the message-driven architecture because it emphasizes that there are two kinds of events. There are two kinds of messages, there are commands and events, right? Two kinds of messages that will be important later. So you have these commands, and at the very beginning, until you know any better, your commands are the params, okay? And sometimes it's good enough. It's usually good enough at the beginning, sometimes later. And in those params, you have the intent, what the message is trying to achieve. And to actually exactly know what they are trying to achieve, you need to know the request path and so on. But that's the beginning. But there will be time later when that's not enough. And maybe you will introduce some form objects, and you will realize that params are just not good enough. I can't have everything in this hash, I don't know what's going, and you introduce form objects, they're kind of okay, but only for some time. Because at some point, you will have like a very big form, very complicated one, and someday you realize that this very complicated form that is posted with just one request to your system is not one command, it's like 5 commands, or 10 commands, or 15 commands. It's just, we have this way of interacting with our application that is doing one HTTP request, but the user intent is that he or she is changing a lot of things in our applications. So we have these commands which are telling you what the user wants to do with this system, right? So I see that the price is okay, this seat is free, so I have book entrance command, and I give the seat, and that's my request to book this seat for the conference that I want to see. And if everything's go okay, if the seat is still free, if no one took it in the meantime, then our service or aggregate or whatever can accept that request and publish an event that the entrance was booked and this seat was taken. So commands are the things that our users want to do, and events are those things that happened, that was accepted. This is fact, this is actually what happened. And usually, the commands are issued, are requested by the users looking at our system and deciding to do something. But what would happen if the commands were coming from the system itself that we write, from the robot that we try to automate? How would it be like? Okay? That's what we are going to talk about. So here's an example of a saga. It's a long story, it has ups and downs. Vikings could tell it to their children. So it goes like that. In our system, where you book tickets to conferences, festival, and so on, you have this ability that if you If you don't have a mobile phone, if you don't have a printer or don't know how to use, you can add this additional service that you want the tickets to get printed and delivered to you via postal, okay? So first you create an order, you place an order, then you add additional service, like postal added to order. You said that you want the postal to be there. Then you pay, so we have this payment paid, and then you need to fill out some postal details. So we have this event which is called postal address filled out. And in the meantime, while you are adding your postal details, which can be very quickly if you have autocomplete, there is a background job generating PDF with the tickets for you, okay? And here is an interesting thing. We don't exactly know the order in which those things are going to happen. We weren't sure whether we are going to put filling out the postal address before something is paid or after. We were worried that if we ask customers for their address before they pay for the tickets, then they won't be willing to add the postal service because they will see that they need to fill out the address, so the conversion might not be that good. And on the other hand, we were worried that if we request them to fill out their address after it's paid, they will be so happy that they got the tickets that they won't look at the screen, which tells them that they need to fill out one more form. So we weren't sure whether you will fill out the details before or after it's paid. So right now it's after, but even there, we are not sure whether you fill out the data before the PDF is generated or after. So these events can come in a different order. We are not sure. But when those 4 events happen at some point, we want the 5th thing to happen, which is the command send PDF via postal, okay? So we've got those 4 events, and when they all occur for a given order, we need to trigger the 5th command. That's our Saga. These are those kind of things that I will be talking about. But this is where we are right now, after 2 years. It wasn't there at the beginning. So the question is, how did we get there? So first, as Andrzej told you yesterday, you start with publishing events, okay? So you have a service, someone can register, the user is created, and after they registered, we publish an event, user registered by email, okay? And when we publish this event in Event Store, it's saved in database, and if there are any handlers, those handlers are triggered. So that's the very beginning. And it's a very simple, very small event, just 2 attributes, nothing fancy. But it might be that you can publish much bigger event with a lot of attributes in much more complicated case with some value objects and other stuff, okay? So sometimes it's very simple, very small, sometimes it's very big. Both cases are okay, both are good. You will need both of them in your system. So that is step 1. We are publishing events. Nothing is happening. They are just saved in database. So then you start introducing handlers, and you realize that they are good, and they do good things for you. So this is a very simple handler. It's adding the user who just registered to the Elasticsearch database so that our admins or customer support can find them by some attributes using full text search, and they can find the user that needs help when they call them, okay? It's a very simple handler because all it needs is the event and its data and it doesn't need to do any kind of query. It's just taking the data from the event and putting it somewhere else. You can think of it as it's building read model in Elasticsearch, okay? So it's a separate read model in Elastic that let us find user by their attributes. And it's very simple. But not all handlers are that simple. This one is sending emails, but it needs to find the email configured in database. So when a football club comes to us and it imports people who has who are the season pass holders who can go to every event when they play at home at their stadium. We import them and we want to welcome them in our system. We want to give them a way to set a password. But to do that, we need to know which email to send for which club, so we check on database which mailer should we use, okay? A bit more complicated handler, but still not that complicated. Does some queries and triggering mailer. Okay. But later, at some point, you will realize that you can use one class, one handler, to handle multiple kind of events in the same way, okay? So here's an example. We have two events which sound very, very similar. One is ticket refunded, and one is ticket canceled by admin. Sound very similar. From the point of the scanner bounded context, in our application, scanner is bounded context responsible for letting you in or not if we scan a barcode. And you might be thinking, well, that's kind of simple. Why is that a separate bounded context? Well, that's because if you have like some more complicated events, you need to let people on multiple days. Sometimes there are requirements which entrance they need to use on the stadium to enter the stadium. And if you start like going deeper into the ticketing industry, there are very interesting bounded contexts, and scanning the ticket is one of them. It sounds very simple for very simple cases. You just scan the tickets and go in. But the bigger clients you have, the bigger customers, the bigger venues, the bigger festivals, the more days, the more complicated setup, VIP people, and so on, it gets more and more complicated. So in our system, it's a separate bounded context. And this bounded context is interested in both events, is subscribed to ticket canceled by admin and ticket refunded. And in both cases, when this thing happens, we revoke you the access. There is revoke command invoked, okay? But when the ticket is canceled by admin for whatever reason, maybe you were misbehaving on a conference, I don't know, it's only that you are revoked the entrance, okay? You are not allowed to enter. But when the ticket is refunded, there is much more things happening, okay? Like Salesforce and reporting is interested that we got this money to someone else and we need to update some read models or some financial statements. We no longer have this money. When your ticket is just refunded by admin, we still have this money. You are just not allowed to enter, okay? But from the point of view of scanner-bounded context, one handler can handle two events in the same way. And if your handler can handle more than one kind of event, like 3 kinds of them, but it needs also a state to make some kind of decision, then you've got yourself a Saga. That's how we reach it. So here's an example. We have conference created and conference cloned event that we handle and ticket kind created, okay? And when the conference is created on or cloned based of their last month's setup or last year's setup to make the setting up faster, we just store some data in database like who created this conference, what is the tenant, what's the ID of this event that was created, and so on. We just store some data. And when the first ticket is created for that conference, we issue check bank settings command, which is responsible for checking whether this organizer already filled out payout details, and if not, it will email them that, hey, you want to earn some money on our system, but we don't know how to pay it out, so go here and fill out the details, okay? But to know how to trigger this command, we need to have the data that we stored when we were processing the previous events. We need to know the event ID, we need to know who's the organizer, and the ticket created thing don't have this data, but the event published earlier that the conference was created or cloned has this data, so we can use it we can take this data from the previous event, we can combine with the fact that for the first time the ticket was created in that conference, and we can trigger a command. Easy. So here is another example. Payment paid too late. Here goes the story, okay? It's a saga. So you placed your order, you said that I want to buy tickets for this conference. But in ticketing industry, usually there is like hard limit how much time you have to pay for your order, like let's say 20 minutes in our case. Because you can't keep the places reserved like continuously all the time for you until you would gladly like to pay for us, okay? There are other people who would like to come to Wrocław RB conference. They might have the credit card already. They are willing to pay us the same money. So maybe if you can't find your credit card in 20 minutes, you are not worthy coming here. And maybe someone else should be here, right? Because you should be prepared. It's 20 minutes, and it's not that hard. So your order can expire. But say you already were on the payment page, you were already providing us the credit card details, and you submitted them, and the payment went okay. So the payment was paid, but your order already expired. What do? So we authorize the amount of the transaction, the order amount on your credit card, but we haven't charged it yet. So we still don't have this money, just logged on your credit card. And then we can decide, okay, let's issue a release payment command. We will give you the money back. You won't have the order, you won't have the tickets, but we won't have your money, okay? We are covered, everything is okay. People see that the amount is no longer locked on their credit card. And if the tickets are still there, we will tell you, okay, you can try again. Maybe this time you will be faster than 20 minutes, okay? But the important thing is that there is one bounded context, is about orders, about the fact that you place an order and it expired. And payments is a separate bounded context. And yes, we got the money, but we can't give you the product. So the Saga is now saying, okay, release the money back to the customer. We never had it. So these are those kind of stories that we are doing right now with sagas. You have multiple bounded contexts, you have events coming from them, and the saga are orchestrating the job, the payment process, and things like that between them. They are mediating, transforming events and things that happened in one place to things that should happen in a different place. So this was the story. This was how we got there in 2 years, okay? It wasn't 1 week, it wasn't 2 weeks, it was a longer story. So assuming that you want to be there, assuming that you want to have those sagas, what kind of things you should look for, what should you avoid, how to not get yourself into problems. So the first thing is that I showed you synchronous handlers, which are executed like immediately after the event is published. This is their API. And the API is similar to REST API. You just have one perform method, okay? And usually in perform method, we initialize the handler. If there are any dependencies, we pass them. And we call the method call, okay? That's a very simple API. And the fact that we use the perform to create new instance and initialize with dependencies is useful in tests, because in tests, you can just initialize the handler yourself, pass the dependencies like stub dependencies and so on, and you can easily test the handler because it's just using normal way to create a class and pass dependencies. Okay. But you need to be really careful with your synchronous handlers, okay? So imagine that in our case of the user registered handler, when we want to send something to Elasticsearch, and Elasticsearch is not working because something, okay? We have networking problem or Elastic is down, whatever. So imagine that user registered, you publish the fact that the user actually registered, you made the decision, and then you start processing the handlers. And the first handler is that one which adds the user to Elasticsearch. And it doesn't work, there is an exception. So if you don't catch this exception, it will bubble up, okay? It will bubble up and roll back the whole transaction like the user never registered. And that's no good. You have like multiple bounded contexts in your applications, like multiple small subsystems, like here's one, here's another, here's one. And just because somewhere there Elasticsearch didn't work and we couldn't save this user in Elasticsearch doesn't mean that something here won't work or here or here or here, right? Those things can work just fine. So just catch the exception, send it to Honeybadger. Maybe your developers will look at it later. It's okay. So something wrong went here, but everything else went okay, okay? And if we need to fix it, we need to fix it here in this one place. Otherwise, if we let the exception bubble, everything will be rolled back, okay? So this is important. And if you publish those events, remember to name them like with some kind of intention, with context. So don't give me like user created, user updated bullshit, okay? It's user registered by email. That's a very specific thing. If the user joined from Facebook, the user joined from Facebook. It's a different thing. And if the user was imported from a list by someone, then the user was imported. They were not created, they didn't join by email, they didn't join from Facebook, Google+, Twitter, or anything else, they were imported. So name those events like accurately, and you will have like much better intuition, much better into DDD what's actually happening in your system. So you have these sync handlers, and what's the biggest win? So I showed you these service objects, and we used to have like very big service objects taking a lot of dependencies, like 5 or 7 or sometimes even more. And you have those big service objects taking a lot of dependencies, and at some point you realize that those dependencies that are used in the service object are not used to make a decision whether the user can register or not, okay? They're only interested in the fact that the user actually registered. And then you realize that you put all those dependencies in the service object which don't belong there. The service object should just either reject the command, so the user cannot register because email is taken or whatever, or it can, and everything went fine, okay? But the fact that you now introduced publishing events and the handlers means that you can move the logic of side effects of the fact that someone registered into the handlers from the service objects. Let the service objects just decide whether something happened or not, okay? Whether it can happen or not. And if it happened, publish event, and the side effects are moved to the handlers. And your service object will suddenly get smaller and smaller and smaller, and you will realize that you didn't need all those dependencies there anyway. They were just interested in side effects. User registered, and you need to have it in Elastic, maybe in a report, maybe email needs to happen, whatever, maybe some invitations were accepted, so now we can send that, oh, your friend entered. These are all just side effects. Okay. Async handlers, tough shit. So yesterday, Andrzej told you, don't go async. But at some point, probably, we will want to go async. And here is a simplified version of the very core of the event dispatcher. So when the event is published, it's saved on database in the event store, and then it looks into registered handlers, iterates over them, and dispatches the event, okay? And you have synchronous and asynchronous handlers. So the synchronous handlers are just executed immediately. So it's the else clause, okay? We serialize the event and we give it to the event handler and execute immediately. And in our case, just to go simply, if the handler is supposed to be executed asynchronously, we just put it as a job on rescue. Nothing fancy, simple rescue, already obsolete, too old, not maintained, it works. Okay, so, but this is a simplified version. This is actually more real version. So here's the problem with asynchronous handlers. If you publish an event and trigger an asynchronous handler, it can be picked up by REST job very quickly, so quickly that it might not, the transaction might not even be yet committed, okay? So if the handler wants to find, for example, the user created on database, it won't be able to find. It's running in a separate process. The transaction is not committed yet, and it can't find the event, okay? So what we did, we are actually putting the jobs on REST after the transaction is fully committed, okay? And the way we do that is we use the same mechanism that Race is using in Active Record. We subscribe to an after commit callback. We use something that mimics the Active Record interfaces, and it works. So if you are inside a transaction and you schedule asynchronous handler, it will only be put on rescue after the transaction is committed. So if it tries to find anything on database that was done inside this transaction, it will be able to find it. Okay, I told you that we serialized the event with YAML. And that might seem like an interesting odd choice. Why YAML? Why would anyone do that in the world? Okay, so here's the thing. YAML works. And without defining the schema for the events, you can serialize value objects. Like, for example, the seed in our system is a value object. It has a label and category. It's a very simple value object. And you can use YAML and serialize, and when you deserialize, it will be a value object again. So you have value objects in your events instead of primitives. And YAML, contrary to some very popular serialization engines, can serialize date and time. And if you deserialize them, they are not strings, they are date and time. This is awesome. And so these are the strengths of YAML. We didn't think it very true, like very much. It just works, okay? So we are using YAML still. It's an odd choice, but it works. Okay, in asynchronous handlers, you can rewrite the exceptions, okay? If there is an exception, it's a separate rescue job. You can just rewrite it, and the exception will appear on the rescue list of failed jobs. So when you go and fix the bug or the networking problem, whatever caused it, you can just click one button in Resca and retry this asynchronous handler and fix this one bounded context that for a moment didn't work well. Okay, this is a bit complicated, but I think you will get it. So I told you that the events that are running into Saga, that are triggering it, they can happen at any time. They can happen at the same moment, even probably. But when you need to make decision based on the events, you want to process them one by one in a serialized way, okay? So if you have the state of your Saga somewhere in database, I just use Active Record because why not, it works. Then you need to make sure that you process the events one by one. You need to decide on some kind of order because you are going to make decision based on the previous event and the one that came right now. So we have, let's say that there is some state already in the database. You already have the record, okay? So the thing that protects you from processing those two events at the same time is the log, find, or create. So it will do select for update, it will log the record on normal SQL database, and that prevents you from two processes accessing at the same time the state. One will get through, and only when the one gets through, the other will be allowed to log the record again and go through as well. And what protects you in the case when there is no state on the database yet is the add index with unique record. So it works the same way when the record is not yet created on the database, the database engine will log the one handler trying to create it, and the other will get through, And when the one goes through, the other will now get an exception that, hey, the record is already created. So it will retry, and then it will find the record created by a different handler, and it will go through, okay? So that's what makes us safe, that the events are processed one by one, even though they could happen in any order. So when the event actually happened and we need to process it, well, we want to call something. We want to remember the fact, probably. So this is a very simple thing. The postal form was filled out. We know the address. And now we call the filled out method, we pass current time, and we pass an adapter, okay? This is what we do. And then we have 4 methods which are very similar. They do nothing else, but they just update Boolean flag. It's just not Boolean, but the time, but it doesn't matter. It's just like a Boolean flag. They save the state, and they try to trigger the command, okay? Maybe send via API, okay? So here is the maybe send via API. It checks whether all of the things that are required to happen already happened. It checks, was it added to basket, paid, filled out, and generated, and have we not already triggered this command? And if all those things happened, then we execute the command. In our case, we transmit the PDF via the adapter to the post office so that they can send it to us. Okay, but this is not so cool. This is not so good. Why? Because this method needs an adapter or a service object to execute the command. And where does it get it from? Well, it gets it from one of these 4 methods, okay? But where do they get it from? Well, they get it from the handler, who needs to know how to instantiate or find the adapter or service object and pass it down. So here we have it, and we pass it down, and we pass it down, and then here we execute it, right? Completely unnecessary. Because there is a better way. And the better way is to use command bus. So at the beginning, I told you that in message-driven architecture, you have 2 kinds of messages. You have commands and events. And we were talking a lot about event store, the fact that it publishes, saves on database events, publishes, it triggers some handlers, and the service or whatever publishing the event does not know anything about the handlers. It does not know who's gonna process the handlers, how, and when. And what if we had a second bus, a message bus this time, for putting commands on it? In such case, our Saga wouldn't need to know anything about the adapter or the service object. It wouldn't need to know who's gonna process this command. It's only interested in what's triggering this command and triggering the command indeed by putting it on the command bus. And then the bus, maybe synchronously, maybe asynchronously, would find a service object that registered for processing those kind of commands, who's capable of saying whether they can go or not. And it would execute it. And then our Saga wouldn't need to know anything who's doing it, when, and how. It only needs to know that it needs to put the event on the command bus. And that's the story. So thank you very much. That was it. That was how we went to Sagas in last 2 years. And let me show you, share with you one more personal story. So in my entire life, I made $15, I shit you not, $15 on open source software. It was one donation. Someone was very happy about my active reload library, that it got him working faster in development mode. And I got $15. I used it to buy flowers for my wife. That was it. Poof, gone. Okay? But me and my company in Arkansas, we made $50,000 on selling knowledge to developers by writing the books. Okay? So apparently there is something in people that makes them want to buy books. They don't have a problem with spending $50 on a book. That's the normal price on our book when it's ready, and no discount applies. But they are not so much willing to pay for your code, okay? So if you want to earn some decent money, please write books and people are much more willing to pay for them. It works much better. So spend half of the time writing the code and the other half writing blog posts, having mailing lists, contacting people, making making them friends of you, sharing your knowledge. This works better. So if you like the talks, if you like what we are doing in our company with our blog, newsletter, and so on, just buy one of this book to support us, and I can give you even an invoice for that. It's legal, no problem. So yeah, that's the message. Thank you very much.